let's do partial indexes. So we're going to go back here. We looked at gin. I'm going to copy this query really quick. Actually, we can probably just grab all of these. So we're going to be looking at category names for just a second. So specifically, category names. So we're going to be looking at category names. It has a category ID, a name, and a language. Fathom for a moment, this is an enormous table. It's actually not small. So select count star from category names. You can see 36,000. It's not 0. Let's say that we have an English website that 99.999% of our traffic is all English, but we do have a German language as well. Most of our users are going to be querying against just the English part and really don't need to have the German parts indexed. If I say create index on category names, all of the German stuff is going to get indexed, which would be wasteful for most of our users. What do we do about that? Well, you can actually add a where clause in your index. So, and you can see here, select distinct language count star from category names group by language. You can see we mostly have English and German category names, but less than a third of our table is, not less than a third, less than half anyway, is English. So it'd be useful if we could only index on that side. So let's go grab this query right here. If we do that, you can see, get a sequential scan, and that's going to be about 832. But let's go ahead and create this index here. So we're going to say create index, whatever you want to call it, index English category names on category names language where language equals en. So now we have an English language index. So if I run that same category or that same query again, notice I get way better times. So I went from a setup time of 132 and a execution time of 641 to 905. Or so, no, this is 132, right? So basically all that setup time ended up being, that's interesting that it ends up being the same. Oh, it is the same as that. Got it. Okay. So anyway.
So will it only use this index when you have a where clause for English?
Correct.
Okay.
So the planner can see that your where clauses matches up and it's able to use those together. So you can see I went from 832 down to 641. A small improvement. The setup time is pretty big, and when you add those where clauses, the setup time gets bigger, right? Nonetheless, it's it's 25% better-ish. It's not nothing. But let's run that same query again for DE. And we're right back to that 832, right? So it's actually only doing part of it. In our case, if I was actually really doing this, it's probably about the same speed. In fact, we can even just try it and see what happens. I actually haven't tried this. What did I call that index? IDX something or other.
IDX English category names.
There we go. And then we will create that again, and we'll just drop this where clause. Try that again with the English names. So we went from, I think, 672 to 674. Nope, 641. 30 units. That's an effectual time. This was 993 to 987. So that's just going to be on the how busy is my computer right now kind of thing. But now if I go back and I do that, this one, this will also get the same benefit. So you can see this one took 3893, probably because it wasn't cached and probably for, I don't know, other reasons as well. So in this case, if this was a code hot path, I'd probably just loop in all the German stuff as well. Might as well. The performance benefits of including German was not that big. But if there was 1 million entries in this database or 1 billion, it would make a big difference. So all these trade-offs to be making in your head. I just want to show you that you can do partial indexes.